Hey guys, today we are going to talk about inequalities that we can find within a triangle. So on this triangle right here, we are going to mark the largest angle and the longest side. So we'll just start with that. The largest angle, and I'll put an L on that right there. That is the largest angle. And here is the longest side. Okay, then we'll mark the smallest angle. So that's right here. And the shortest side is right here. So something we should notice is that the longest side and the largest angle are opposite each other. Okay, so largest angle and longest side are directly across from each other, so they are opposite each other. We should also notice that the shortest side and the smallest angle are opposite each other. Okay, so we've got the smallest angle and the shortest side across from each other. Okay, that will always be true. Largest angle and longest side will always be right across from each other. Smallest angle and shortest side will always be right across from each other. And that leads into our first inequality within a triangle. If one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So if the length of segment AB is greater than the length of segment BC, and here we have that shown, AB is 8, BC is 5. So AB has a greater length than BC. Okay, so if that's the case, then the angle across from AB, the greater length, is the larger angle. So angle C, the measure of angle C, is larger than the angle across from the smaller side, BC. So the measure of angle C is greater than the measure of angle A. And it works the other way as well. If one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. So here we have a larger angle. This 50 is larger than 30. So across from this 50 is the longer side. So the length of segment BC is longer than across from the 30-degree angle, the length of segment AB. Okay, so a boat leaves a dock and travels 2,500 feet to a cave. So here it starts at the dock, it travels to the cave. Okay, so it's 2,500 feet to the cave. Then it travels 5,000 feet to a beach, and then 6,000 feet back to the dock. One of the angles in the path is about 55 degrees, and one of them is about 24 degrees. What is the measure of the angle found at the cave? So here's the angle at the cave. I want to know that measure, knowing that two of the angles are 24 and 55. Now we have to remember a triangle makes 180 degrees total. And since I only have two angles here, I can do 180 minus those two angles to get the measure of the third angle. So 180 minus 24 minus 55 is 101. Okay, so the three angle measures are 24, 55, and 101. Okay, so the smallest angle is across from the shortest side. 2,500 feet is the shortest side, so here is 24 degrees. The largest angle, which is 101, is across from the longest side. Here's the longest side, 6,000. Across from that is the largest angle, which means the 55 goes here. So what is the measure of the angle formed at the cave? It is 101 degrees. So we want to list the sides of this triangle in order from shortest to longest. So we'll put shortest, medium, and then long. Okay, so we start by looking for the smallest angle. The smallest angle is 45 degrees. Across from that, or opposite that angle, is the shortest side, which is segment QR. Okay, the largest angle is here, 80 degrees. Across from that is the longest side, and that is segment PR. And the remaining side is segment PQ, and that is the medium side. A boat makes a trip whose paths has sides of 1.5 miles, 2 miles, and 2.5 miles long. Okay, so the boat makes a triangular path with those three side lengths. And the angles are 90, 53, and 37 degrees. Sketch and label a diagram with the shortest side on the bottom and the right angle at the right. There is only one way that we can possibly draw this if we follow all these directions. So we've got the shortest side on the bottom. So down here will be 1.5 miles. That is the shortest side. And it's going to have the right angle at the right. Right here is going to be the right angle. Okay, and then, so that's our 90. So we've taken the 90 and the 1.5 out. We just need to place these two angles in these two sides. So we'll continue the path, turn it into a triangle here. 90 is the largest of the three angles. Across from that is the longest of the three sides. So across from this largest angle, we've got the longest side, 2.5 miles, which leaves 2 miles left over here. Okay, now the smallest side, 1.5, across from that is the smallest angle, 37 degrees. And the remaining angle is 53 degrees. Now the triangle inequality theorem. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. So if I add up the lengths of any two sides of a triangle, what I get from adding them up has to be bigger than the third side. So let's just say I add up the length of side AB and BC. I can guarantee that whatever I get by adding these together is going to be greater than the length of AC. Or if I add the lengths of AB and AC, so if I add these two lengths, the sum that I get will be greater than this third side, BC. Or if I add the lengths of BC and AC, so now I'm adding these two lengths, the sum that I get here will be greater than this third side, AB. So no matter what two lengths I add together, I'm guaranteed to have something greater than the third side. So if we had a triangle, let's say with sides of 4, 5, and 6. If I add 4 and 5, that's 9. That's greater than 6. If I add 4 and 6, that's 10. That's greater than 5. If I add 5 and 6, that's 11. That's greater than 4. Okay, so let's say I have three lengths of, say, 4, 2, and 9. If I add 4 and 2, that's 6. Oh, but that's not greater than 9, so these lengths cannot make a triangle. Okay, so these three lengths could make a triangle. These three could not. How about 5, 5, and 10? Okay, so if I add the 5 and the 10, that's 15. That's greater than 5, so that's okay. If I add 5 and 5, that equals 10, but it's not greater than 10. So I could not use these three to make a triangle. If I had 5 and 5.1 and 10, that would be okay because 5 plus 5.1 is 10.1, which is greater than 10. So these three lengths could make a triangle. So not just any three numbers in the world could be side lengths of a triangle. They have to be numbers such that no matter what two I add together, I get something greater than the third side. So a triangle has one side length of 14 and another side length of 10. Describe the possible lengths of the third side. Okay, so if sides are 14 and 10, the third side could be the shortest side, it could be the longest side, it could be the medium side, but it can't just be any number in the world. So let's just say the third side is going to be the shortest side. If I subtract 14 and 10, 14 minus 10, I get 4. Okay, so if I tried to use 4 as my third side length, 4 plus 10 is equal to 14, not greater than 14. So I can't actually use 4, but I can use anything that is greater than 4. Okay, but let's just suppose that the third side is the longest side. So I'm going to do 14 plus 10, and that is 24. So now my three sides are 14, 10, and 24, but 14 plus 10 equals 24. It's not greater than 24. But I could use anything less than 24. So that third side can be anything that is greater than 4, but less than 24. I can't use 4 and 24, so not equal to, but I can use something that's bigger than 4 and less than 24 to be my third side of the triangle. So if a triangle has two side lengths of 23 and 17, if I subtract those, 23 minus 17, I get 6. Okay, 6 plus 17 equals 23. So I can't use 6, but I can use anything bigger than 6. Okay, now we'll assume that the third side is the longest side. 23 plus 17. And 23 plus 17 is 40. 23 plus 17 equals 40. It's not greater than 40, so I would have to use something less than 40. So my third side has to have a length that is bigger than 6, but less than 40.